Hello everyone. Today we are going to talk about one of our body system, which is the respiratory system. We are breathing right now, right? None of us are holding our breath. I believe so. Okay. So this is what we are going to talk about, respiratory system. There's a difference between breathing and respiration. Okay. What I am doing now, me as an organism doing just now and now actually is what we call breathing, taking in air and bringing it out. That's breathing done at organism level, while respiration is actually something take place at cellular level. The cells are the ones which do that respiration. And why and how? I mean, it's actually because of the presence of one organelle inside a cell called the mitochondria. Mitochondria is the part, the organelle inside the cell which do the respiration process. Okay, and this process is so very important because through this process, the cell will be energized, will obtain energy, get energy, and as a whole, the organism will be also able to be energized, yeah, through respiration. So this is the equation of respiration. This looks fancy, but this is not really what we need. So this one is the better one, I think. So what happened is, what is actually happen as we are doing the respiration. This is the cellular respiration, okay, guys? So what happened in the respiration process is actually the burning, oxidation of glucose here, C6H12O6 glucose, the food that we eat. It's from the food that we eat. The food that we eat will be burnt, will be oxidized by oxygen. Oxygen, please pay attention on how it's typed, okay? Because there are characters which are subscripted and there are others which are normal. When you have to do this handwritten, then it should be correct, okay? So we see here that 6 molecules of oxygen oxidize the glucose, okay, C6H12O6 plus 6O2. It produces, the reaction produces 6 molecules of carbon dioxide in the form of gas, of course, and 6 molecules of water. And the rightmost part, you see ATP. That's an energy molecule, because actually, guys, the main idea of doing respiration is to obtain energy. Okay, we need to breathe, we need to respire, because we need to be able to continue our life, and for that we need energy, and this is why respiration take place. Okay, so carry on. So these are the organs of respiration, and starting from here, the nostrils. Okay, the air will enter our body through the nostrils, but actually we can breathe in through our mouth, right? Yeah, of course, but there are things our mouth cannot do. Okay, when we breathe in through our mouth, like everything will just enter our body, and that's not safe at all. So we need, it is highly recommended if we breathe in through our nose, because when we breathe in through our nose, what will happen to the air we breathe in are, first, the air will be filtered, because we have the we've got the nose hair inside there. I don't want to show you, okay? I don't want you to have a close look on it, but we have hair inside this hollow space there inside, yeah, inside our nose. So the hair will filter the air. So if there are dusts dust or whatever, it will be prevented from entering. Okay, so that's good. Filtered, it will be humidified, it will become humid, and it will also be warmth. Okay, three things our mouth cannot do. That's why breathe in through our nose. Okay, so nostril, nasal cavity, it's the cavity inside the nose, okay, in which the three processes take place: the filtering, and then warming and humidifying. Okay, and then the air will pass, will continue its journey in, and it will pass this pharynx. Okay, pharynx. Pharynx I always explain as the intersection, okay, because the food that we eat will pass through pharynx, and the water we drink will pass through pharynx, and the air we breathe in will pass through pharynx. It's like a intersection. Okay, now so from the pharynx it will enter the larynx. Okay, the larynx consists of several parts. We got the larynx box here. On top of the larynx box, we got the vocal cord, right? And at this larynx box, in male humans, we got this enlargement. Okay, this the Adam's apple. Okay, so this is the larynx box. The larynx will be continued by the trachea. It's cartilaginous pipe. Okay, it got cartilages along it. Okay, all along it. So trachea will be branched into two, one to the right, one to the left. Remember, whenever we are looking at a picture or diagram which is anatomical, which shows us anatomy of something, what you see on the left is the right, what you see on the right is the left. Okay, so the trachea will be branched into two tunnels, right and left. These are called bronchi. Bronchi is the plural form of bronchus. Okay, so bronchus will be branched further, and yes, here we got the two lungs, right lung and left lung. Okay, I'm going to go to the next picture. So from here we see that this is the nose, nostril, and the nasal cavity, and then here's the pharynx. Actually, pharynx. Okay, this is the pharynx. So food and water will pass through pharynx, air will pass through pharynx, and related to the system, respiratory system, we will continue the journey to the trachea. Larynx is over here, trachea, bronchus, and then it will branch into bronchioles or plural bronchioli. Okay, from this diagram we also see something new information, for additional information, which is there are three lobes found on the right lung, and then there are two lobes on the left lungs. Okay, carry on. So this is more or less the same. Okay, I'm going to go with this one then. So bronchus, and then bronchus will be branched into bronchioles, and at the end of bronchioles we got millions of these sacs called alveoli. That's plural, and alveolus, that's singular. It's a sac, tiny sac, surrounded by capillaries here. So the wall of the sac itself is so thin. The wall of the capillaries are also thin. This allows the gas exchange. Okay, so after we breathe in, the air will enter all the way down and reach the alveolus, and then the oxygen taken from outside will be sent to the blood vessels, capillaries in this case, to be distributed to all cells in our body which needs oxygen, right? So these are the organs. Now, this is the device used to measure the volume of respiration, called spirometer. Okay, now Why am I showing you this? Because see, as you are now sitting down or maybe standing up, whatever, watching this video, you will continuously breathing, right? None of you are holding your breath, right? So when we in normal condition like this, breathing in, breathing out, I guess it's very unlikely for us to do that extremely, right? Like breathing in and then breathing out as strong as we can. No, we won't do that, would we? So we will breathe normally, okay? So there will be a certain amount of air coming in and then a certain amount of air coming out, okay? Inhaling, exhaling, inspiring, expiring. We can measure that volume of air, okay? So let's see. We are breathing in and out, in and out, in and out, like that. The volume of air coming in and out as we are breathing normally is called tidal volume. Tidal volume, okay? In this case, the volume of tidal volume is about 450 cc's, right? 0.45 liter, okay? That's tidal volume. But after a normal inhalation, normal breathing in, like that, can you continue to breathe in further? Yes. Until we cannot breathe in anymore. So, the forced inspiration, like that, will get a certain volume of air. We call the inspiratory reserve volume. Inspiratory reserve volume. And in this case, it says that the inspiratory reserve volume is about 1.55 liter. Inspiratory reserve volume. The amount of air we can still breathe in after we do a normal inhalation. Okay. On the other hand, after a normal exhalation, can we still push to breathe out? Yes. Don't do that when you are having a flu. Yeah, it will yeah, it will be funny. Okay, so you can do also a forced exhalation, and the volume of that action is called expiratory reserve volume. In this case, it's about 1.5 liter of air. We call it expiratory reserve volume. So tidal volume, the normal breathing volume, plus inspiratory reserve volume, plus expiratory reserve volume is called vital capacity. Vital capacity. Vital capacity is the total amount of air able to come in and out of our lungs. Yeah, that's the vital capacity. But no matter how strong you breathe out, no matter how strong you exhale, there's no way we can be able to get rid of all the air from our lungs. No, there will still be air inside our lungs, okay? And that's important because we cannot allow our lungs to collapse. It needs to stay expanded. That's why we need this amount of air stay in our lung. The amount of air stays in our lung is called residual volume. Residual volume. Yeah, here in this diagram says it's about 1.5 liters. So this is residual volume, the volume of air which will not go in and out. It will stay there inside the lungs. Okay. So actually, beside having this volume of air, vital capacity, which can go in and out, our lungs can also contain the residual volume. Okay, this tells us that the total volume of air able to be contained by our lungs is 5 liters here, 1.5 the residual volume, and 3.5 the vital capacity. That's what we call the total capacity of lungs. So that's it. Another visualization of this concept idea, and another one. So tidal volume, expiratory, inspiratory, residual, and this is what I made in bahasa Indonesia. So ada volume tidal, volume waktu kita bernafas secara normal, ya. Lalu kemudian volume cadangan inspirasi, ya, ini adalah udara komplementer. Volume cadangan inspirasi itu udara komplementer, volume udara yang masih dapat dihirup setelah inspirasi normal. Dan ada volume cadangan ekspirasi, expiratory reserve volume. Ini disebutnya udara suplementer. Ini komplementer, ini suplementer. Volume udara yang masih dapat dihembuskan setelah menghembuskan nafas secara normal. Total volume tidal ditambah volume cadangan inspirasi ditambah volume cadangan ekspirasi, atau volume tidal ditambah udara suplementer ditambah udara suplementer ditambah udara komplementer disebut kapasitas vital paru-paru. Total volume udara yang bisa keluar masuk paru-paru. Oke. Dan seberapa kuat pun kita menghembuskan napas, saya tidak bicara tentang nafas terakhir, ya, maka akan ada volume sejumlah udara tertentu yang akan tetap tinggal dalam paru-paru, disebut volume residual. Nah, kapasitas vital paru-paru, udara yang bisa keluar masuk, volumenya berapa, ditambah volume residual udara yang tetap di dalam paru-paru, ini membentuk kapasitas total paru-paru. I guess that's it, guys. Hopefully you can understand. You got further question, never hesitate to contact me. Your assignment today is to draw respiratory system, human's respiratory system. Okay, draw it, take picture of it, and submit it in our Google Classroom. Okay, thank you very much. God bless you. Stay healthy, stay safe, and stay happy, because that's important. Goodbye.
Be strong.